Hi guys, this is Saurav here and welcome to another session for online Pathshala, the Vedantu's initiative to make education affordable to all the people no matter where you are, wheresoever you are present, from the best educators online. Now, as you all know, we have started with the physical chemistry series, and the physical chemistry series has started with the topic solutions and colligative properties, which we also call liquid solutions. The first session was already conducted on Monday, and if you haven't watched, please do watch it again. The session was about concentration terms. That was the first thing that we had to identify, that what is a solution and what is concentration term. Akash, I'm fine, thank you, thanks a lot. Okay, so today is the second session, and the second session is about a very important concept that we would be taking forward and using, which we would be analyzing a lot of other phenomenon that is known as vapor pressure. What is vapor pressure? Okay, so let's start today's session, and if you guys are excited, just let me know. Chalo, Mohammed Khan, love from India. You're from Pakistan, love from India. Okay, I'm fine, thank you guys. Hello Ankesh. So guys, let's start with today's session. And in this session, the first thing that we would do is take up the problem that I had given you as the homework in the last class. The problem which was given to you as the homework was this. In this problem, I had asked you to calculate I had asked you to calculate all the relevant concentration terms. For example, this question was about molarity. Okay, ये question molarity के लिए था, लेकिन molarity के अलावे इसमें आपको बहुत सारी चीजें calculate करनी है. So, if I try to start with the calculation of molarity, then number of moles of NaOH would be written as 20 upon 40, because 40 is the molecular weight, so that is 0.5, and in volume in liters is 500 ml, which is 0.5 liters. Okay, this turns out to be equal to, the molarity turns out to be equal to 1 molar. Molarity is 1 molar. This is very easy. Molarity is 1 molar, and this is the easiest part. लेकिन इसके आगे हमें बढ़ना है. Okay, I had also told you that the density of solution is 1.5 gram per ml. Okay, this was told to you that the density of the solution is 1.5 gram per ml. अब ये 1.5 ग्राम पर ml हम यूटिलाइज करेंगे मोलालिटी कैलकुलेट करने के लिए. तो मोलालिटी अगर हमें कैलकुलेट करना है, if I have to calculate molality, then I need to know the number of moles of NaOH, which is already known, and the mass of solvent in kgs. Now, how do I calculate the mass of solvent in kgs? I take the mass of solution and subtract the mass of solute. So I'll write over here, mass of solvent is nothing but mass of solution minus mass of solute. What is the mass of solution? Volume of solution is 500 ml. Density is given. So mass per unit volume is density. So density times volume gives us the mass. So it turns out to be how much? 15.5. कितना होता है? 75. Okay, so this is 750 grams. Mass of solute is how much? 20. So we have 730 grams of solvent. 730 grams of solvent. If we have 730 grams of solvent, I will write 0.5 by 0.73 as the molality. Okay, this will be the molality. Okay, this will be the molality. Furthermore, if I want to calculate mole fraction, how would I calculate mole fraction? I need number of moles of NaOH by number of moles of NaOH plus number of moles of water. Okay, I need both of them. Number of moles of NaOH is 0.5. This will be 0.5. And 730 grams of water would be equal to 730 by 18 moles. Whatever answer that you have to get over here will give you the mole fraction of NaOH. Mole fraction of water would be 1 minus this value. Okay? Is this clear? If this is clear until now, please type yes in the chat box. If this is clear until now, please type yes in the chat box. Okay, very good. Now, if I want to calculate weight by weight percent, W by W percent, how would I calculate? How would I calculate? W by W percent का definition क्या था? What was the definition? It is the mass of solute in 100 grams of solution. Mass of solute in 100 grams of solution. What is the mass of solution taken over here? 750. तो 750 में 750 grams of solution contains 20 gram of solute. So 100 gram will contain of solution will contain 20 by 750 times 100. That would be your weight by weight percent. This will give you your weight by weight percent. Weight by weight percent times 10 raised to 4 will give you ppm. I had already told you weight by weight percent. If I want to calculate ppm, that will be weight by weight percent times 10 raised to 4. Okay, so this times 10 raised to 4. So, and ppb is weight by weight percent times 10 raised to 7. Okay, is this understood? So hamara take this information, and without using any elaborate formulas, I can end up calculating everything. Okay, I can end up calculating everything. Fine. So Abhishek, Tolanur, please, I need Vedantu help. You are writing that. You can mail us, but I will not be able to take your question right now if it is non-academic. Okay. So this was discussed in the last class. ppm is weight by weight percent times 10 raised to 4. ppb is weight by weight percent times 10 raised to 7. ये 10 raised to 4 और 10 raised to 7 कहाँ से आता है? क्योंकि weight by weight percent हमने 100 ग्राम ऑफ सोल्यूशन में कैलकुलेट किया है. ppm हम कैलकुलेट करेंगे 10 raised to power 6 10 raised to 6 grams of solution में. So this times 10 raised to 6 will give you the right answer. Okay. Okay, so is that clear? If we will you also teach inorganic chemistry? If it comes to that, okay, if it comes to that, I'll also teach inorganic chemistry. But right now we are discussing normality and formality. Normality is normality requires n factor. Okay, normality requires n factor, and formality is something which is an obsolete concentration term. We don't use formality anymore in calculations, in chemical calculations. Okay, so let's proceed ahead. So with this, we finish the concentration terms. And we start with a new concept which is known as volatility. Okay, no, formality is not there in advanced syllabus. It's not there in the main syllabus. उसकी ज़रूरत भी नहीं है. इतने सारे कंसंट्रेशन टर्म्स हैं कि आपको फॉर्मेलिटी की ज़रूरत भी नहीं पड़ेगी. ठीक है. सो हमारा आज का कंसेप्ट है वोलेटिलिटी, और व्हाट इज द प्रोसेस ऑफ व्हाट इज अ वोलेटाइल सब्सटेंस. सो व्हाट इज अ वोलेटाइल सब्सटेंस? यू मस्ट हैव सीन एसीटोन ओवर हियर. यहाँ पे पेट्रोल भी आपको दिख रहा है, डीजल भी दिख रहा है, एंड यू आर सीइंग दिस थिंग इज लिक्विड ब्रोमीन. All of these liquids have a tendency of very rapidly evaporating and changing into the vapor state. Okay, ये सारे examples जो आपको दिख रहे हैं, all of these examples are for those substances which even at room temperature very rapidly convert into vapors. So if I place some acetone in my hand, it will very rapidly convert into vapors. Okay, so all of these examples tell us about the give us an example of what is volatility, which describes the tendency of how easily a substance vaporizes. How easily a substance vaporizes. So volatility is that. What is the relation between volatility and evaporation? देखो, volatility and evaporation, Abhishek Tolanur, this is not the right forum where I can tell you this, okay? Later on, that will be discussed, okay? This is not the right forum. So, volatility and evaporation. So, evaporation involves the change of phase. मैंने आपको पहले बताया था कि what is a phase? Phase describes a state of matter. So if I take the liquid phase changes to vapor phase, and that is called evaporation. That is called evaporation. While evaporation takes place, the chemical nature of the substance doesn't change. So it is very, very important to know that the chemical nature of the substance doesn't change without changing the molecule. Doesn't change. Chemical nature change नहीं होता है, सिर्फ उसके molecules vapor state में पहुंच जाते हैं. What is volatility? Volatility is essentially the tendency of a liquid. It measures the tendency of a liquid to evaporate. Okay, evaporation एक process है, वो सारे liquids में होगा, लेकिन volatility उस liquid के vapor में convert होने की tendency को measure करता है. Okay, so if I look at acetone and I take water, दो example हैं, acetone and water. Acetone और water में कौन सा ज़्यादा volatile है? Which is more volatile between acetone and water? Acetone is present in nail polish, even in turpentine. Not in turpentine. Acetone is present in paint. So, what is more volatile? Acetone is more volatile, so acetone will evaporate faster. Acetone will evaporate faster. Okay? Chalo. What happens when evaporation takes place, or when a volatile substance evaporates or any substance evaporates? जब कोई सी चीज का evaporation हो रहा होता है, then molecules from the surface go into the vapor state, and if we take a volatile solvent, then ये liquid solvent है, इसके surface से molecules vapor में move कर रहे हैं. The solvent molecules are moving into the vapor state. The solvent molecules are moving into the vapor state. Now, what happens is, suppose I cover the liquid. What will happen? These vapor molecules are not escaping into the atmosphere. These vapor molecules are not escaping into the atmosphere. ये यहीं पे trapped है. So over here, vapor molecules are present. Okay. These vapor molecules are present inside the container. Also, आप देख सकते हो कि कुछ arrows नीचे की तरफ बने हुए हैं. It means these vapor molecules will keep colliding on every part of the container, and some can recollide on the surface of the liquid. So, what will happen is a process where condensation and evaporation will take place simultaneously. जैसे ही आप container लगा देते हैं, उसके container के ऊपर आपने एक vessel रख दिया, तो this will undergo evaporation and condensation simultaneously. Okay, so this is an evaporating solvent, and evaporating solvent enclosed in a container. So there are certain molecules which are evaporating, certain molecules which are condensing. Okay, with this concept, let's understand what will happen next. What will affect the volatility of a substance? Can you tell me what will affect how quickly a molecule escapes? एक रीजन है ये दे सकते हैं हम कि if I look at the intermolecular forces, if I take water, then water has hydrogen bonding. Water has hydrogen bonding, and acetone, if I take acetone, acetone only has dipole-dipole interaction. This is the negative end of the dipole, positive end of negative end, positive end. But over here there is a hydrogen bonding, which is a stronger force. Can you tell me which is a stronger force? Hydrogen bonding or dipole-dipole interaction? Hydrogen bonding or dipole-dipole interaction. Hydrogen bonding, Siddiq, एकदम सही बोला है. हाइड्रोजन बॉन्डिंग इज अ स्ट्रॉन्गर फोर्स ऑफ अट्रैक्शन. ओके, रिमेंबर दिस, हाइड्रोजन बॉन्डिंग इज अ स्ट्रॉन्गर फोर्स ऑफ इंटरैक्शन. इसीलिए एट रूम टेम्परेचर water doesn't evaporate that rapidly, but acetone evaporates rapidly. Okay, acetone evaporates rapidly. Also, there is one another way to identify this. If you look at the force of attraction, then the force of attraction in hydrogen bonding is 1 by r to the power 3, while in dipole-dipole interaction it is 1 by r to the power 4. So if the distance is taken into account, then according to this equation, hydrogen bonding turns out to be the stronger force of interaction. Okay, hydrogen bonding turns out to be the stronger force of interaction. So if the intermolecular forces are stronger, then the tendency to remain in the liquid state will be higher. The tendency to go into the vapor state will be lower. It's very very obvious. अगर आपका attraction ज़्यादा होगा solvent phase में, तो vapor phase में जाने की tendency कम हो जाएगी. So if intermolecular forces increases, volatility decreases. Okay, what is Brownian motion? What is Brownian motion? The random motion of particles. The random motion of particles. If I look at Brownian motion and I look at the random motion of particles, intra मतलब within the molecule. Intra means within the molecule, and inter means दो molecules के बीच में. Okay, so if you hold your hand, that is intra. If you hold someone else's hand, that is inter. Okay, दो चीजों के बीच में इंटर बोलते हैं उसको. Now Brownian motion, random motion of molecules. Now random motion of molecules, you know, can be increased by increasing their kinetic energy. Very good. Deveshwar, yes, condensation is similar to particles settling down. Yep. So if the Brownian motion, the rate of Brownian motion needs to be increased, don't I need to increase the kinetic energy? And आपने gaseous state में पढ़ा है that for increasing the kinetic energy, what do I need to increase? I need to increase the temperature. So when a gas particle, if liquid molecules can overcome the intermolecular force of attraction, so if I increase the temperature, if temperature increases, volatility increases. Okay, if the temperature increases, volatility increases. Okay, so दो फैक्टर हमें पता चल गए, फोर्स एंड टेम्परेचर. इसको आप याद रखिए, ठीक है. अखिल बोलू, हैव यू नॉट रेड काइनेटिक थ्योरी ऑफ गैसेस? Increase in temperature will make the molecules move apart, will make the molecules escape the vapor state, escape the solvent phase and go into the vapor state. This you must have already learnt in kinetic theory of gases. Okay, so what is the term vapor pressure? What is the term vapor pressure? Volatility जो हो रही है, how do we measure that how volatile the substance is by a term known as vapor pressure. How volatile a substance is by a term known as vapor pressure. So a measurement of volatility is known as vapor pressure. A measurement of volatility is known as vapor pressure. Now when you take a liquid, आप एक ऐसा काम कीजिए कि you take a liquid and you put a container. Okay, you take a liquid and you put a container. This liquid molecule will start escaping. Liquid molecules will start escaping, and after a while you will see that the level of solvent is decreasing. ये level of solvent decrease करता रहता है. Okay, the level of solvent is decreasing. After a certain time you will see that the level of solvent remains constant, becomes constant. Why is it becoming constant? Because initially what happens is that the vaporization process is faster. पहले वेपोराइजेशन होता है, वेपोराइजेशन होके वेपर्स बनते हैं, एंड देन आई एम नॉट टेकिंग अ सोल्यूट, सोल्यूट तो लिया ही नहीं गया है, सिर्फ सॉल्वेंट ले रहे हैं. ओके, वी आर नॉट टेकिंग एनी सोल्यूट ओवर हियर. सो द solvent molecules move and also the vapor molecule which is formed start condensing. They start condensing. So initially the vaporization rate is more than the condensation rate. This happens initially. This happens initially. But a situation arrives in which the rate of vaporization and the rate of condensation becomes equal. Lipika Chauhan, how can solute be water? How can solute be water? Okay, solute, how can solute be water? I have taken the solvent एक ही चीज दी गई है. Okay, solute तो water हो ही नहीं सकता है. So at equilibrium, what will happen is the vaporization rate and the condensation rate will become equal. When they become equal, that is the state. उस state पे जितना pressure यहाँ पे है, जो vapors बने हैं, these vapors will impart some pressure on the surface of the liquid, and this pressure is known as vapor pressure. This pressure is known as vapor pressure. So the pressure exerted by the vapor at equilibrium at a given temperature is known as vapor pressure. Anish, yes. What is the application of this vapor pressure? The whole topic of solutions is explained only because vapor pressures are important. Okay, जितने भी phenomenon आप देखते हो, जैसे कि when we talk about boiling, when we talk about freezing, when we talk of osmosis, all of these are dependent on vapor pressure. Okay, relative lowering of vapor pressure is not going to be discussed in this class. We'll be discussing it in the next class. Okay, fine. And these lectures are important for JEE as well. So at equilibrium, the pressure that the vapors will exert on the surface will be known as the vapor pressure. Okay, vapor pressure. Hitesh, focus on this. Okay, focus on this. Now if I want to know what are the factors that will affect the vapor pressure, what can I say is that vapor pressure will be higher. अगर मान लो कि मैंने acetone लिया है, if I have taken acetone, let's say in a container I have taken acetone, and in a container I have taken water, and I have covered it. I have covered both of them. Okay, if I have covered both of them, in which case we will be having more vapors over here. In which case we will be having more vapors. Acetone will be higher, so more vapors will be more. In this case vapors will be less. Can I say that acetone case में vapors ज़्यादा रहेंगे? अगर vapor ज़्यादा है, more vapor molecules are present, so more pressure on the surface of the liquid. Can I say that? If more vapors are present in the container which contains acetone, then won't the pressure over here also be higher? Yes. So over here vapor pressure is higher, over here vapor pressure is lower. Okay, it's very obvious. So can we say that vapor pressure is proportional to the escaping tendency? The molecule or the solvent in which molecules escape very easily will have higher vapor pressure. It is thus proportional to the volatility of the liquid. If it is more volatile, then the vapor pressure will also be higher. Yes, that's it. So first factor which affects vapor pressure is volatility. So volatility increases, vapor pressure increases. Cool? Next, if I look at distribution of molecular speed, whenever I take ideal gases, I'm considering ideal scenario over here. I'm taking ideal scenario over here. So if I take ideal gases, you must have seen this plot. ये plot आपने देखा है. You must have seen this plot. What is this plot known as? कोई बताएगा? What is this plot known as? This plot is known as, anybody? What is this plot known as? Kinetic energy, number of molecules, or you can take fraction of molecule. It's not Boltzmann. It's known as Boltzmann, Maxwell-Boltzmann distribution. Maxwell-Boltzmann distribution. Okay? It is known as Maxwell-Boltzmann distribution. Now, Maxwell-Boltzmann distribution का ये कहना है कि at a given temperature, the number of molecules which have very high energy is very low, and the number of molecules which have very low energy is also very low. Maximum number of molecules will have average energy. थोड़ा बीच में रहेगा इन सब के बीच. ये आप एक नॉर्मल सिनेरियो में भी आप देख सकते हैं. If you take any class of 100 students, the number of people who are scoring very high will be very small, and the number of people who are scoring very low will also be very small. Most of the students will be having an मतलब कोई बीच में, इन दोनों के बीच में ही रहेंगे. Okay, so this is what Maxwell-Boltzmann distribution of molecular velocity suggests, or kinetic energy suggests. Now if I increase temperature, मैंने टेम्परेचर इंक्रीज किया तो क्या किया मैंने? आई हैव इंक्रीज द काइनेटिक एनर्जी ऑफ मॉलिक्यूल्स. सो द नंबर ऑफ मॉलिक्यूल्स विच नाउ हैव मोर एनर्जी विल ऑल्सो इंक्रीज, and the number of molecules which have less energy will decrease. This is very, very obvious. So if I take a solvent and I heat it, I am increasing the average energy of all molecules, so the rate of vaporization will increase, and consequently the rate of vaporization will increase, and consequently the volatility will increase, consequently the vapor pressure भी increase करेगा. राज वर्मा मैं तो बोल दिया. ओके, ये बोल्ट्जमैन डिस्ट्रीब्यूशन पढ़ने का मतलब क्या है कि टेम्परेचर विल ऑल्सो बी अ फैक्टर. तो मैंने टेम्परेचर चेंज किया, वेपर प्रेशर भी चेंज कर जाएगा. इफ आई चेंज द टेम्परेचर, द वेपर प्रेशर विल ऑल्सो चेंज. उत्कर्ष, ओके, द पॉइंट इज ऑल थिंग्स विल नॉट हैव न्यूमेरिकल्स. There are a lot of things which require theoretical understanding before we move on to numericals. So just by solving numericals, if you think that you could qualify IIT JEE, then you are mistaken. Okay? Anikesh Pandey, if we increase concentration, that is not gonna affect. It is a property. जिस तरह से ice का melting point होता है, okay? वो आपने ice का amount ज़्यादा ले लिया, you cannot decrease its melting point any further. Okay, it is gonna be a fixed melting point. Okay, vapor pressure कब तक vary करेगा? जब तक आप temperature increase करते रहोगे. एक point आएगा in which the vapor pressure will you increase the temperature so much that all of the liquid goes away. Okay, all of the liquid goes away. So evaporation, yes, evaporation depends on surface area, but over here we are keeping the nature of vessel constant, so हमने यहाँ पे surface area वाला फंडा नहीं लेके आ रहे हैं. Okay, so if I look at this, that as the temperature increases, the kinetic energy increases and vapor pressure also increases. So increase in temperature will increase vapor pressure. Okay, increase in temperature increases vapor pressure. The topic has numericals, but don't hound for numericals. That's not important. जब न्यूमेरिकल्स आएगा तब करवा दिया जाएगा, ठीक है. जब तक थ्योरी चल रही है तब तक थ्योरी समझ लीजिए. अगर सिर्फ फॉर्मूला पे बेस करके अगर आपको न्यूमेरिकल सॉल्व करना है देन पढ़ाने का कोई मतलब ही नहीं होगा. Concepts are very important. Okay, now there is one another way I can explain that why increasing the temperature will increase the vapor pressure. Why increasing the temperature will increase the vapor pressure. Suppose I take H2O and this is liquid, and I take H2O vapors. This is an equilibrium. This is an equilibrium. Now, is this process endothermic or exothermic? Can you guys tell me? In this process, it is endothermic or exothermic, like conversion from liquid to vapor. It is endothermic or exothermic? Ankesh, exothermic. Guys, do you know what is the meaning of endothermic and exothermic? Endothermic में heat absorb होती है. Endothermic involves absorption of heat, and exothermic means liberation of heat. So liquid heat absorb करके vapor में convert करेगा या heat बाहर दे के vapor में convert करेगा? Liquid will take up heat to convert into vapors. So it is an endothermic process. Delta H is positive. It's an endothermic process. Okay. Now, in Le Chatelier principle, okay, in the Le Chatelier principle, you must have heard of this fact that for an endothermic reaction, if you increase the temperature, the reaction moves forward. Endothermic reaction, if I increase the temperature, forward reaction will take place. And if I decrease the temperature, backward reaction will take place. So if I increase the temperature and forward reaction takes place, then more vapors are formed, and if more vapors are formed, then vapor pressure will increase. Okay, if more vapors are formed, then vapor pressure will increase. So because of that, if I want to write the equilibrium constant for this, I will write the equilibrium constant as the pressure of H2O vapors. That's it. By 1, because liquid concentration will be taken as 1. Okay. राज वर्मा, ये पहले एक्सप्लेन कर दिया गया है. वोलैटिलिटी एंड वेपर प्रेशर मतलब एक ही चीज के चट्टे बट्टे हैं. So if volatility depends on force of attraction, vapor pressure will also depend on force of attraction. Okay, so this is the equilibrium constant. The equilibrium constant will be written as the pressure of the vapor. So if I take, there is a Van 't Hoff equation that you know, that in this equation अगर ये दो किसी टेम्परेचर पे आपने वेपर प्रेशर निकालना है, let's say at temperature T2 you want to calculate pressure, and you want to calculate, and temperature T1 pressure is given, then you can just incorporate the value of delta H and calculate the equation. Okay, you can calculate the pressure at a different temperature using this equation. Okay, however, on this equation numericals are not given. It's just an important thing to remember. Okay? Now, if we want to actually know that does the vapor pressure increase with increase in temperature? Yes, there is an experimental proof as well. If we look at the variation of vapor pressure of water with increase in temperature, then you can see that as we are increasing the temperature, the vapor pressure is also increasing. अब देख लीजिए वेपर प्रेशर इंक्रीज कर रहा है. ओके, एज वी आर इंक्रीजिंग द टेम्परेचर द वेपर प्रेशर इज ऑल्सो इंक्रीजिंग. सो दिस इज द एक्सपेरिमेंटल प्रूफ फॉर एग्जिस्टेंस ऑफ द फैक्ट दैट इंक्रीज इन टेम्परेचर अफेक्ट्स वेपर प्रेशर. इस चैप्टर में हम ये करने वाले हैं कि वी विल टेक टेम्परेचर मोर इनटू अकाउंट, because we have to study about boiling points, melting points. So our more focus will be relation of vapor pressure and temperature. Okay, yeah, this is in the syllabus, this is in the CBSE syllabus. CBSE syllabus में जो भी है, that is present in IIT JEE, that is present in NEET. So that's a redundant question. Okay, anything which is present in class 12th chemistry syllabus is present in JEE, is present in NEET. The graph is, why is the graph not linear? There is an equation for that. Okay, there is a mathematical equation for that, to calculate the change in vapor pressure with respect to temperature, and the equation is not in the form of y equals to mx plus c. Okay, it is not in the form of y equals to mx plus c. Okay, now how do you calculate vapor pressure? Vapor pressure calculate करने का तरीका क्या है? Okay, how do you calculate vapor pressure? ये आपको मालूम है, what is this setup? This is a typical barometer. Okay, typical barometer. So this is the height. If you place a inverted tube, the mercury will rise and it will, whatever pressure is exerted, if this height is 760 mm, then the आप बोल देंगे कि external pressure is equal to 1 atmosphere, isn't it? External pressure will be equal to 1 atmosphere. Now what you do is, the method is, what you do is you put some liquid on the surface. कुछ liquid यहाँ पे आप रख दो. Okay, you sprinkle some liquid on the surface of mercury. You sprinkle some liquid on the surface of mercury. रीता यादव, इतनी बार आप लिख रहे हो for NEET, yeah man, anything which is there in 11th and 12th is there for NEET as well as JEE. Okay, fine. So this liquid will also come over here. This liquid will also come over here, and this liquid will evaporate. This liquid will evaporate. When this liquid evaporates, it will create some vapor molecules which will exert some pressure, and with respect to the original height, the height of the layer will change. Okay, with respect to the original height, the height of the mercury level will change. फिर से मैं बता रहा हूँ, अच्छे सुनिए. I take some liquid, the liquid will come over here above mercury and the liquid will evaporate, and due to that evaporation it will create some vapors which will exert some pressure. It will push the surface of the level of the mercury below, and with respect to the original level we can see a difference. Let's say now the height is at 130 mm of Hg. Okay, now the height is at 130 mm of Hg. 630 mm of Hg. Earlier height was 760. So what is the pressure which is created over here? 760 minus 630, which is 130 mm of Hg. 130 mm of Hg. The 130 mm of Hg pressure is the vapor pressure due to the liquid at a given temperature. हमेशा याद रखिए, vapor pressure will be measured at a given temperature. Generally we measure it at room temperature condition, but if we vary the temperature, the vapor pressure will also change. Will the liquid evaporate or when we have to raise the temperature? Will the liquid will evaporate or we have to raise the temperature of the system in which it is kept? I didn't get your question, Deepika. Okay, I didn't get your question. So you can please write it down and make more sense, structure it properly. So this is how we calculate vapor pressure. The last thing that I will tell you today is a very important inference. आपको क्या लगता है किसका वेपर प्रेशर ज़्यादा है, एसीटोन या वाटर? Acetone vapor pressure and water's vapor pressure. Whose vapor pressure is higher? This will be higher. This will be lower. Now, with whatever knowledge of these molecules you have, if you know the boiling point, then boiling point of water is 100 degrees Celsius at at 1 atmosphere. If the external pressure is 1 atmosphere, the boiling point is 100 degrees Celsius and the boiling point is somewhere about 60 degrees Celsius. Okay? Boiling point is because boiling point is 60 degrees Celsius. Now, can we correlate vapor pressure and boiling point? What we can see that if vapor pressure is higher, boiling point is lower, and if vapor pressure is lower, boiling point is higher. Okay? Vapor pressure is lower, boiling point is higher, and vice versa. We will apply the same concept. In the forthcoming topics of solutions. In the next session of solutions, I will be discussing Raoult's law, which explains the ideal behavior of solutions. Okay, which explains the ideal behavior of solutions. So please keep this thing in mind, that what is vapor pressure, because this is vital. And with this, I will end today's class, very theory oriented. If you like the lecture, please do share it and ask your friends that the classes we are conducting. Weightage of this topic, don't worry about the weightage of this topic right now. Try to learn it in a proper manner first. Okay? Henry's lo baad mein padhenge. Okay? So with this, I take leave and join us for the next session of liquid solution lecture 3, which will be on Raoult's law. Okay? It will be on Raoult's law. Okay? Chaliye. All the best, guys, and bye bye.